30 minutes or so, we'll talk about the summit. We'll have a look at the presentations that are coming up as well. Really quickly, I'd like to introduce myself in case you don't know me. I'm Peter Dalmaris. I'm an online educator and maker, the author of Maker Education Revolution and founder at Tech Explorations. I'm the host of the Maker Mind Meld Online Summit. My mission is to help people learn electronics, programming, printed circuit board design, and lots more. Most importantly, I want to help as many people as possible to enjoy the technology education adventures. Now back to Simon. Simon is a customer experience manager with PCBWay, and he has a 5-year experience in the PCB field. Simon is intimately familiar with what happens in the factory floor as soon as you upload your Gerber files, and we'll talk more about this in a moment. Now, before we start, I want to acknowledge the support of our sponsors. As I said earlier, PCBWay is our platinum sponsor. PCBWay is a PCB manufacturer from China with over a decade of experience of producing PCBs for makers and for large companies. Not only they can manufacture your PCB designs into beautiful PCBs, they can also assemble its components so that you can receive your gadgets in the mail and start using them right away. And I've tried this myself, and the plug-and-play experience with no soldering required once you receive your gadget from PCBWay is amazing. Our second sponsor is Altair Engineering, and Altair is our gold sponsor. Altair is a global technology company that provides software and cloud solutions in the areas of product development, high-performance computing, and data intelligence. Of particular interest is one of Altair's model-based design technologies. It's called Altair Embed. Embed is a tool for developing embedded systems by automatically generating code from graphical block diagram models that works with dozens of microcontroller hardware, including the Arduino. Richard Korg is one of the summit speakers. He's going to show us what you can do with this tool in his masterclass. Okay, so that was my introduction. Simon, back to you. I'd like to welcome you again officially to this kickoff event and to thank you for being a speaker.
Thank you.
Now, we'll have a look at the summit presentations in a few minutes because we've got some really amazing presenters, and all of them have done a terrific job in creating original content for this summit. So we'll get to that very soon. Now, before we get to that and then reintroduce Simon into this discussion, I want to explain why I decided to create this summit, because I think this why is very important. It gives you the context of what you're about to experience. So,
Okay.
yeah, I'll tell you a little story. So the Maker Mind Meld Summit is a materialization of a dream that I first conceived back in 2016. It's almost 4 years ago now, in 2019, when I attended as a speaker in a mini maker fair. It was an awesome experience. I remember preparing for my talk. That was an opportunity to think deeply about technology and maker education. And that is a characteristic that I think you also experienced as well, Simon, right? Because you did prepare for your talk. Did you feel that you really had to get deep into your topic? You can't just brush over it, right?
Yes, of course. And after I prepare my presentation, I get another insights or fully understand with my the PCB manufacturing process. Actually, I have really to arrange all the information at one presentation. So it's my opportunity to review my knowledge and share it with the audience. Yeah.
Exactly. There's nothing like presenting on a topic that you're really passionate about, and that really comes through when you do your presentation, and you'll see that with all of our speakers. I felt like this when I was delivering my presentation at that mini maker fair. While I was delivering the talk, like I'm among the background noise of people, there were hundreds of people there talking about their gadgets and running experiments, and they were excited about when they finally figured out how to fix something. And I was there delivering my talk at the same time, and that part was really amazing. And now, I've been a university lecturer for 15 years, and I've delivered thousands of lectures, but it just wasn't the same. None of those lectures came close to delivering a talk or a presentation on a topic that excites me to a diverse group of people. So again, I'm still continuing with the story of why did I create the Mind Meld, the Maker Mind Meld Summit. The problem with that mini Maker Fair, where I was a speaker, even though it was amazing, the problem was that I had to travel for thousands of kilometers. I had to spend thousands of dollars to get there, and accommodation and all that. And I also had to take a couple of weeks off work. So it was a big commitment. Same goes for attendees, like the people that go, and myself included. When I go to an event like that, like a traditional event, I have to travel for a long time, spent a lot of money, time to get to those traditional events. And that is one of the not so good aspects of a traditional summit or a traditional conference. So I thought to myself, there's got to be a better way. Do a summit online. So I thought, how about I try to organize an online summit like a mini Maker Fair, in which makers from all around the world can talk about what excites them, and to which other makers also from all around the world can attend, right? So no matter where they are, no matter who they are, they can attend an online summit. And that was exciting.
Yeah, it's a great idea, actually. Yeah.
Yeah, that's the feedback that I received from a lot of people. It just makes it so easy to do this exchange of knowledge from presenters, from speakers to attendees. And hopefully, the attendees of this summit will be speakers in the next summit, which would be amazing. And as I was thinking about all that back in 2016, I didn't know how to do it. I was thinking about different ways by which this could happen. I spent a few years trying to figure it out, and finally, here we are. Okay, we started work in August earlier this year. Now, a few months later, December the 7th, the summit has begun. And that's why I feel amazing right now. So my hope, that's all why I did it. Now, what do I hope to get out of that? Especially, how do I hope that this is going to help our attendees? So my hope is that our speakers' knowledge and their drive to create technology magic, as I call it, will inspire our attendees to create their own magic, so they can go on and inspire others who will then go on and create their own magic. You can see it's a virtuous circle. And that is what I want to achieve from the summit that you are now participating in. Okay, so
that's really
that's
great.
my why, right?
Actually, that's also the reason why our PCB want to sponsor this event, and I also want to join in this event. It's really wonderful way to share our knowledge with the world. Yeah, everyone can join in us. Yeah.
Yeah, well, we are lucky the time that we live, and actually have the opportunity to do what we do. It's just the best time ever, I think, in world history, to be able to connect people from all over the world and engage in something that we love doing. And I think you, Simon, and PCBWay, of course, but all of our sponsors and all commercial companies or for-profit or non-for-profit companies, we basically all help each other do the thing that we love doing. And that's what I really love from opportunities like this, to get together with people, with companies, with people from companies, and as makers, just use this inclusive word, makers, we all work together to learn and to create magic, right? And I've got some questions for you, Simon, later on to tell us a few things about the maker movement and making in general from the perspective of a company like PCBWay, who deals with a lot of makers every day from around the world. So I've got some questions for you coming up. Okay, so Simon, you've been with PCBWay for around 5 years now. So in this time, you've interacted with a lot of people, a lot of makers from all around the world. These are people that send you the PCBs, the PCB designs. Actually, I should be more careful with my term. So PCB designs, they are in digital files. They send you those files for manufacturing. From an outsider perspective, I'm thinking that as a PCB manufacturer, you've got a special insight into what is happening in the world of making. So makers start prototyping with a breadboard. They do something quickly on a breadboard. They play with it for a while. Then when they become more serious about it, oh, this is something good, I think I want to take it further, then they go on and design a PCB board in software. And most of them send that design to you for manufacturing. So that's when you know that things are getting a little bit more serious with a particular design or a particular gadget. And that's when you come in. So from your experience, could you tell us about the kinds of things that people make, like maybe things that you picked up in the last couple of weeks, for example, and how, and also in terms of volume, over the last 5 years, how did you see that volume of designs that people bring you to manufacture is increasing?
It's really a tough question, actually, and it indeed a great increase through the past 5 years. So PCBWay has been growing year by year, and we have about 200 more new members registering on the website and choosing PCBWay as their manufacturer. And I think the increase in members is because that more and more people want to customize their own electronics products, and they want to build their own projects, which may change the world. And every small project was start from an inspiration or just an idea, and our PCB always encourage innovation, encourage creativity, and to bring the ideas to life. So we create a new user interface through our website and make everything easier. So this way, more and more people found it much easier than they thought before, than their experience before. So they want to have a try, and after they try this, they fall in love with these new features. So more and more people join us, and our community become larger and larger. And this is benefit. This benefits actually from the new features, the easier way to produce manufacturing the boards.
Yeah, this is something we're going to talk about as well in your presentation. I remember when I made my first PCB, I used a printer, designed the PCB, and I can't remember what tool I used, and I printed it on an inkjet printer, and I ran off to a company that made it. I got on a bus to do that. They didn't have an internet or web interface, so got on a bus, and then I had to wait for about, I think, 3 weeks. Went back on the same bus to go to the same company to pick it up from. And just that process was just really hard. And, just prototyping iterations were very expensive. And I never manufactured another PCB until around 2010. It's almost like 20, maybe 15 years later. And things had changed a lot. And now I did my last PCB, I think a couple of months ago. It's just a very easy, seamless experience, and I think that adds to the experience of creating an electronic prototype, and you can now get the quality of prototyping that an actual company would have in its lab, but now you can do it on a hobbyist benchtop, and I think that is amazing. So companies like PCB really add to the tool set of a modern maker to create magic using technology. So Simon, I've got another question, again, drawing from your experience. At PCB Way, what are your customers like? Like, I'm thinking, what is the mix of hobbyist makers, students who are in some kind of engineering degree, professional engineers for prototyping for the businesses? Do you have some statistics to tell us what the percentage share of makers, of hobbyists, is in your customer base?
Actually, our customer base contains actually different groups. They're makers, they're professional engineers, and even from the engineers from bigger company. We all know, for example, the microchip or Apple, and different groups. And all they want is to build their own prototypes, small project. So we don't evaluate their orders based on their background. So
Right.
we build their products in the same way to encourage them to bring more wonderful projects. And
yeah, I was about to ask you about that. So there's no difference whether you are Apple ordering a PCB like for a prototype from you or myself, the same thing.
Yes, all we focus on is their projects, if it's core or not, if it's a wonderful project or not. Yeah. We also sometimes we also talk about with our colleagues and about the cool project. When we first look at their Gerber files, we've been amazed, and it looks cool, and I want to get it. I also want to build this project. They always give me and give us the inspirations to build new products. Yeah.
Yeah, and you have part of your website, I think the community part of your website, where people can publish their projects. So you can make a design public, and anyone can manufacture one of those and try it out. So that's part of like open source hardware, I guess, and that's your contribution to it. Yeah.
Yeah.
Great. It's amazing. All right. Well, thank you, Simon. How about we have a look at the presentations that are coming up this week? You ready for that?
Yeah. Can't wait.
Okay, we've got some amazing stuff coming up. So let me share my screen. So here's you. This is what we're doing right now, actually. Right. So this is the kickoff event. We are just talking about the event. How about that? It's very meta. Now, later on today, in about an hour, there are, I think, 3 or 4 presentations coming up. See, I'm used to saying lectures because I've been using this word for 20 years. These are presentations, a bit different. All right, so there's Mark Wilson. So Mark Wilson is a software developer. He's a senior software developer, actually. He's been doing this like for, I don't know, 30, 40 years from New Zealand. And he's going to show us how to create animation and graphics using an Arduino. And like, when you think about the Arduino, you don't think about graphics. Like, that's not the first thing that comes to mind. It's a very limited device, and still Mark was able to get animation happening. So he's built a clock, and as the time changes, it's got these. It's a flip clock, so it's got these cards, like these virtual cards, that display the digits of the clock flipping. That's why it's called a flip clock. So it's going to talk.
It's a really cool project.
Yeah. There's a BCP there, of course. Mark is built it using, I think, plexiglass enclosure. Very nice hardware implementation, but the focus here is on the software. So that's the first one. Right off the bat, you get something really amazing here. If that's not enough, the second presentation that goes live just in an hour from now is from Zafar Iqbal. So Zafar doesn't like simple projects. He likes complicated projects. So what he's built is an Arduino implementation of a Turing machine. Now, you may have heard of Alan Turing. Simon, have you heard of Alan Turing? There's a movie about him as well.
Yes, I know a little about Turing machine. It's actually, I don't think it would be an easy thing to make it. So I actually curious about how the FAR will talk about it with us.
Yeah, it goes quite deep in it. So a Turing machine doesn't have a model implementation. So Alan Turing designed the machine in conceptually. So it's a calculating machine, but he never actually developed a hardware example of it. So a lot of different implementations have popped up. And if you go to Wikipedia, you'll find a lot of different variations of the Turing machine. So Zafar, what I really like about his presentation is that he got something that is quite involved, and then he translated that to make it work on the Arduino. And that included the user interface design, plus, of course, the programming itself was quite difficult, and he had to come up with various software techniques to try and make that work. So there was a lot of constraints, and through those constraints, Zafar was able to build a machine that actually works flawlessly, as he says. It's battle tested because he's taken it to maker fairs in places like New York and Rome, major maker fairs, to display it to his audience. And it's got a few, and Zafar also has a special offer. If you watch his presentation to the end, you have a chance to win something. It's going to give you a gift. So this is definitely something different with watching it. Now, Joao, you're going to love this one, Simon. So Joao, I was from Portugal. His presentation is about how he created his own Arduino clone. Like creating your own Arduino clone is probably one of the best ways to really learn well how to design a PCB if you've never done it before. It's one of those projects that is difficult enough to stretch you so you can learn, because if it's too easy, you're not going to learn much. So it's complicated enough to stretch you, and it's also useful enough so that whatever you build, you're actually going to use. And the result of this is a PCB on which you put in the various components. So Joao built one of those, and it's actually, his project is also highlighted as one of the best projects on the Kick-off.org website. So you can check it out. That's how I connected this with Joao.
Yes, Arduino is a very common use among makers, and it should be very cool to customize your own Arduino by to add some extra features you want under this wonderful module. It must be very cool.
And shapes. So what Joao was saying was that he wanted to build something that's smaller but also cheaper. Most of the components on the Arduino Uno board are not really needed, and they drive the price up. So if you can throw some of those components away, you can shrink it as well, and it can become a much cheaper Arduino clone for your projects. So Simon, do you see a lot of people like creating their own Arduino clones, then manufacturing them?
In our open source community, there are a lot of people sharing their customized the Arduino project, and they add some new features on the board or delete some features just to make it more fully fits to their own project. So it's a wonderful skill to know how to create our own Arduino. It must be very cool.
I've done one of those myself. It was also one of my first KiCad projects. We could probably find that project on YouTube somewhere. But I think customization is one of the traits of a maker who's graduated from being a very beginner to now being able to change other people's work, make it their own because it fits better with whatever the goal for the project is. So customization, I think it's the core of what makers do. And Joao is going to show us how to do that with KiCad and Arduino clone.
Yes.
Okay. Moving on, there's Jeffrey Benton. Jeffrey is a very interesting maker. So he's done a lot of things in his life, and he's now retired, and he lives north of Melbourne, which is south of Sydney, of where I am. And he's got, at least for me, what looks like a huge shed. So a shed is like a warehouse, and it's filled with machines that he uses to make things. Two of those machines are a 3D printer and a laser cutter, but he's got a few other much bigger ones like that he uses for metalworking because Jeffrey used to be also a tool maker. So Jeffrey, a couple of years ago, got into the Arduino and started learning how to use the Arduino. Before that, he was making things like model boats, for example, little planes and things like that. But once he got to the Arduino, he started making those models actually do things and move. So in this presentation, Jeffrey is going to show us how he's using his 3D printer and his laser cutter plus automation using an Arduino to build a crane. The crane's a big thing. Don't think of a little model crane. It's big. It's my height.
Wow.
Yeah, it's almost about, I think he said 1 meter, 70 centimeters. It's a big thing. He has designed every single component for that model crane himself, and then manufactured and printed it, either using some components came out of the 3D printer, some other components came out of the laser cutter. So it's going to show us all of that. And all that came from Jeffrey learning from various online sources, and he also has a small community of other makers in his area where they get together and talk about these things. So this is like Jeffrey is an example, a very good example of a maker who constantly learns things. And what I really like about him is that, like, he's retired. Instead of playing lone balls, or I don't know what retirees do, but he's making stuff. Right?
Yeah.
That's amazing. Yeah.
Amazing.
Okay. So that is day one. Moving into day two. Day two, which is on Sunday, right, December 8th, we're going to open up these presentations at 10 a.m. That's Sydney time. So we've got two presentations that I think are going to be very inspirational. These presentations talk a lot about the why of making and why making is so important. First, we have Gil Poznansky, and then we've got Jorge de Souza Pires. Now, Gil is a speaker himself. So as you'll see in his presentation, he goes crazy when he talks. First of all, he talks like at 1 million miles or kilometers per hour because he's so passionate about this. And he has a psychological impact on me. Like when he talks, or when he finishes talking, I want to start making things. It's like one of those people. So he uses, he worked in the film industry in Los Angeles. A lot of his approach to making comes from that. He's using a lot of his techniques, a lot of the techniques that he learned there in the set of big movies in his making as well. He's going to talk about how he built a very famous character from the Doctor Who movies or the series. He built a robot. Can't remember the name of the robot right now. But yeah, almost a life-size robot which moves around the remote control, and then how he used this robot to raise money for a child that was sick and needed money for treatment. That is Gil's way to explain the impact that making has, not just on the maker, but also on people, or people around the maker and the community, right? There's a lot of contributions that makers do in the community, both open source, the things that they invent and how those help the world. And then with George, his presentation is obviously it's about context. Now, George has been a maker since he was 10. I think he built his first radio transmitter when he was 10. So he's been making stuff for almost 50 years. His career is amazing. He worked for Apple in Europe. He's a professor himself, semiconductor physics. He has a very strong interest in art, and he's written a lot of books. A few of those I have as well. So he's giving us, in a nutshell, the history of making over the last, say, about 50 years. He's showing us what a silicon bar looks like, where in the semiconductor industry, just take a little wafer of that silicon bar and use it to build microchips. It's going to show us how he's done that, and it's going to show us some of his inventions as well, and some of his art too. So George is like the all-round maker who's looking back in his life, and his life is characterized by the things that he's learned, the things that he's made, and the things that he's taught other people. And that's what this presentation is about. So if you need inspiration, keep your Sunday free. Day 2, right? You're going to get a lot of it here. Yeah. Now, day 3, which is the Monday, I hope you're not doing anything, because it's going to be a big day. We've got John Evans, John Teal. We've got you, Simon. Right? So we've got 3 presentations. I call it the how of making. These are tools that, this is actually about tools and about things that we do with making. So first, John Evans talked about open source software and hardware, basically open source projects. And he is an open source project leader at KiCad. So he's in the inner core of the people that develop KiCad. And he's going to use this experience and his know-how to explain how it's all done to us. So if anyone here wants to contribute to an open source project, whether it's hardware, software, it doesn't matter, or wants to create one themselves, then you must watch John's presentation. Okay, it's got everything you need to know to get started there. Then John Teal. Yeah, right. You're familiar with him, right, Simon?
Yes, of course. He is actually our judges, one of our judges for our third PCB design contest. And I invited him to be our judge because he is actually an expert in electronic design and has many years of experience in this field. So I very admire him, actually.
Me too. That's why I invited him. He's amazing.
Yeah.
He's a very approachable person. Like, it's amazing how easy it was to get started. His specialty, right? Like, he's done a lot of things. Like, he's an accomplished engineer. His specialty right now, and what he's really passionate about, is to help people commercialize their electronic designs. So. Yeah. So as we said earlier, makers will start with a breadboard and then they might build a prototype on a PCB. But what happens after that? Like, if you want to commercialize your design into a product that will do well in the market, there's still a lot of work to be done. And most of us, myself included, don't really appreciate how difficult it is to do that. There's just so much going on. I've got to admit that at some point in the past, I was considering developing some hardware products. I did a bit of investigations, realized how hard it is, and decided not to do it. It's just too risky, right? So John, in this presentation, is going to demystify the process. There are 15 steps that all need to be executed flawlessly to get your product to market. Before you do anything relevant to that, watch John's presentation, and that will give you a much better understanding of the process so that you know what you're up against. Right, so there's John Teal. And then Simon, do you want to talk about yours instead of me, since we have you here?
Yes, I just want to share some knowledge that most of people curious about. That is a PCB manufacturing process. And a lot of customers just ask our customer service representatives to share some basic knowledge about how PCB is made. So I want to just grab this opportunity to share this information to all of the audience. Yeah.
Yeah. Thank you for that. We talked about your presentation, and even though there are a lot of materials about this on the internet, especially on YouTube, you can find, and I think you do have some on your channel, the PCB Way channel. There are videos that other makers have made that have visited your factory, and they have video recorded the process. And I am linking to those videos in your presentation page. You can use those as a supplement. But what I like really about your presentation is that you go into the details and you put everything is like in order. So we know exactly what happens and when it happens. And then, of course, you end with advice. That advice is very useful because they help people design PCBs that are cheaper to manufacture, which is important for prototyping, and also better. Like sometimes we just overshoot the engineering specification. We do things that are not really necessary. They don't add anything to the project, just make it more expensive. So
I just want to share an easy way for the audience to better understand, easier understand the whole process. It's not very complicated after you know it.
Yeah, exactly. So definitely, this is like a really good presentation. It's going to make you a better designer of printed circuit boards. All right, and then we go into day 4.
First
Technology you should know about. You should really know about these things. Now, this was really difficult. You see, it's packed. So we've got Dr. Simon Monk, got Dr. Carsten Schulz, Richard Kolk from Altair, and Jason Long, and Bernard Blanchon. I think this is the biggest day, and Jordan Christman. This one is packed. And it was hard not putting any more in here because there's so much that you need to know. This is just a distillation of all the things that makers should know. And I'm sure I'm going to get emails from people saying you should have edited that and this and the other. And I know I should have probably edited another 100 lectures in here or presentation, but maybe next time. So there's Dr. Simon Monk. You're probably familiar with him, Simon?
Not really.
That's totally
Sorry.
okay.
But I'm familiar with this project, Macrobit, and it's a very useful project, educational project, and it's very good for school students to learn electronics. Yeah.
Exactly, and programming in particular. So Simon is an author. He is very well known. I've got a couple of his books, and actually use one of his books in particular. It's about electronics for the new inventor. Very often, like almost daily.
Yeah.
And he's written a lot of other books, and he's also one of the regular presenters at major maker fairs. In this particular presentation, he's talking about the Microbit, as you said, Simon. The BBC Microbit is our microcontroller based on our powerful microcontroller device. It's very popular in schools because of how easy it is to program it. So it runs a MicroPython interpreter inside the chip so that you can just connect it to your computer with a USB cable, and then you can program it in Python. There's nothing in between. And there's also a variety of languages that are available for it, including block language, and that's why it's popular in schools. It's a graphical language which kids that can't read yet can use to program the microcontroller. And the Microbit has got sensors and actuators on it. So it's got an LED matrix, it's got sensors for, I think, magnetometer and what else? A temperature sensor as well, LEDs and things like that. So you can actually start doing useful things without connecting anything to it. Unlike the Arduino, where to do anything useful other than blinking the LED, you need to connect other things to it. So anyway, what Simon is saying is this in this presentation is that makers, not just students, should take a look at the microbit because it is actually a very versatile platform. And in his presentation, he's going to show us some projects that he's built. He's got a book written about this and some very interesting projects that you can attempt yourself. So that's the first one. Then we've got Carsten. So Carsten's presentation is about his technology that is used to help people, that actually teach people how to design their own microprocessor, their own CPU, right? So, again, this is technology that is used, that Carsten is using in schools. So he goes to schools and presents to students and teaches students how to design a CPU. What I really like about his presentation is that, these days in making, and especially in education of technology, we try to make things as easy as possible. Mm-hmm. So to teach how to program a microcontroller, for example, instead of using assembly code, like when I was a kid and I did my first, and I started learning programming, I actually had to use a little bit of assembly code in my Apple IIe. So I had to understand registers and I had to understand bits and bytes and gates and things like that. But in modern days, we don't do any of that. We go to graphical languages, or we go to Python, and there's a huge abstraction between the hardware, where the microprocessor is, and the software, where the programmer sits. So what Carsten is saying that maybe we should go down to the bottom, down to the bottom of the stack, where the hardware is, and teach people how a microprocessor works. And the best way to learn how something works is to make it, right? So I'll show you how to make a microprocessor.
Yes.
And
I really want to learn.
It's amazing. He will show you how to build your first 4-bit microprocessor that can add it can do some simple things like add two numbers. It can address memory. It can put instructions and data into registers, so then it can do the calculations. You're going to put a clock there so that you can time all the components of the microprocessor together. And, once you do that, once you build a 4-bit microprocessor, it's just incremental complexity to get to like an Intel, Xeon microprocessor. It's just incremental, but the beginning is very hard. So that's where Carsten comes in. All right. Next, we've got Richard. So Richard works for Altair. Altair is a gold sponsor. And
visual coding.
Yeah, visual coding is not just for kids. I said earlier when I was talking about the microbit, we can use Make code to program it. So Make code is a block-based language, right? So we have this thing in our mind that visual coding or block-based coding is for kids. And Make code, there's a limit to what you can do. But now let's go to something that professionals use, like Altair Embed, right? So what Richard is going to show us is how he uses the Embed integrated development environment that Altair produces to create control algorithms for a robot. So this is the same process that they use to create control algorithms, so to write firmware for industrial machines, like industrial robots, or for professional drones. So drones that are not just a toy drone, but something that, say, a surveyor will use to survey land, or you can even find those things in the military or in avionics of commercial planes. So this is technology that is used at the top end of town. Professional engineers use it. That's why I say here that visual coding is not just for kids.
Yeah.
Right? So this is going to be, I call this a mastermind, a master class, because it's going to be packed with a lot of information, and all of that comes from Richard's long experience into using things like that for companies like Boeing, right? Mm-hmm. Serious stuff with a lot of stakes and people's lives in stake. All right. Then, Jason. So Jason's presentation is about embedded design. So Jason is an author. He's an electrical engineer. His specialty is working with ARM Cortex-M processors and writing firmware for them. He's also, apart from his book, he also trains people to create such applications. And he was recently actually in China developing one of his courses. And we caught up with him as soon as he got back from China. So in his presentation, Jason is going to talk about the principles and guidelines for developing embedded applications, and he's going to talk about the tools, both software and hardware, that you can use to do that, and will give us a few directions for the next steps as well. So why is this important? What can I say? When I look around me, I just see so many things that are embedded devices. Like here's a little remote control. It's an embedded device. Here's a little keyboard here, embedded device. My battery that's actually charging my phone right now, it's got a microcontroller in it. It's an embedded device. It's running software. So these are the kinds of things that, here's another remote control. So,
it's widely used in our daily life.
Yeah. It's very hard to find things that are electronic these days that are only based on passive electronics, and there is no code running inside of those things. As soon as you put a bit of firmware, then you've got an embedded device, and that's where Jason's presentation is very handy. It's a good way to begin understanding how it all works.
Mm-hmm. Yeah.
Okay. John, Simon, quick question for you. I'm not sure if you know that, like, of the designs that you see regularly coming through the PCB, how many of those a percentage contain only, slots and pads for passive electronics only, versus those that have provision for a microcontroller or a microprocessor?
Actually, a lot of PCB project contains the microprocessors, because you want to give a complex features, functions. You need the microprocessor, because a microprocessor is a brand of an electronic product. You want the electronic product more smarter, then you need to contain a microprocessor. So about more than half of the project that produced on PCB way have microprocessors.
Yeah, that's quite a lot. That tells me that most of us actually do create embedded applications. We just don't know the principles behind them, right? We just do it without actually knowing that what we're doing is embedded design. So Jason is going to give us some principles here. So definitely worth watching his presentation. And then moving on to Benoit. So Benoit is a software craftsman, right? When he writes software, he really takes care to create software that is bug-free and basically perfect, that performs well, especially in a confined device like a microcontroller. So it takes a lot of care to do that. The other thing that Benoit does a lot is that, like with most of us, most of the things that we create these days and the microcontroller powered applications create tend to talk to other devices, very often through the internet, right? So we call it the Internet of Things. So those devices need to talk to each other. What Benoit is talking about in his presentation is JSON. So JSON is a lightweight method for devices to talk to other devices via the internet. And in this presentation, is going to show us how we can use JSON both in a manual way, so where our application constructs a JSON message manually, the hard way. And then he's also going to show us how to do it the easy way, which involves using his library. So Benoit has created a library for this specific purpose, which I believe is the most popular Arduino library out there, independent Arduino library that's outside of the Arduino ecosystem. So it's going to show us how to use it. And he's written a book about it as well. Another thing that it's going to show us is some really good programming principles, because one of the chapters in his book are all about that and how to use, especially hard concepts in C programming, things like pointers, for example, and memory management. So that's what this presentation is about. Yeah. And finally, for this very long day, we've got Jordan. So Jordan Christman. He's a specialist with FPGAs. So FPGAs are almost exotic kind of microchip where the internal organization of the microchip changes depending on the program that you write on it. So you can actually create your own hardware microcontroller or microprocessor by writing a specially designed program onto the chip, and then the chip restructures its gates so that it can perform the operations that your program specifies. So in this presentation, Jordan is going to talk about all this. He's going to talk about hardware and the software design tools that he's using, and that I think why should somebody learn how to do this? There are many applications where microcontroller is just not enough. Imagine, for example, that you want to use, you want to create an Arduino security system. I'm just saying, somebody might want to do that. But obviously the Arduino cannot perform very good video processing. So what you can do then is you can take an FPGA, you can program it with the components that it needs to do video processing, recognize a face, for example, and get it to talk to the Arduino, and then the two work together. The FPGA is a specialist in something where the Arduino microcontroller is more of a generalist, and the two can work together. So there's Jordan Christman's presentation. Okay, we're now in day 5. So in day 5, I have dedicated that to Maker education. So we've got Kieran Nolan and Richard Park. It's just the 2 presentations today. So what Kieran is doing is to show us what a school of tomorrow is going to look like and the kind of technologies that are going to influence and in some cases are influencing education today. I always say that Kieran lives in the future, but not just Kieran, his students. So he works at a primary school in Melbourne. I visited that school back in May. It was amazing. I felt like I was in the future. So his students and Kieran in that school, learn by designing their own technology education. So they play around with VR games, but they also make their own VR game. They customize the computers, they build their own computers. They've got their own cryptocurrency. They've got their own, the school itself has got a blockchain, and they've got their own cryptocurrency so they can trade within them, among them. They design their own games and so on. So it's quite amazing. You might ask, how is that all related to education? First of all that is on its own worth learning. Okay, we do live in a high-tech society, and it's on becoming more high-tech, and you have to be technologically literate to be able to thrive in such a society. And so that's one aspect. All these things are worth knowing on their own. But further than that, one of the things that I wish I had learned at school was how to learn. And the only way to learn how to learn is to actually design your own learning pathways. And that's also one thing that Kieran is doing in his school, and he's going to talk about that, right? How do you feel about that, Simon?
I think it's a good way to educate the students. We need to encourage students to make their own projects instead of just learning theoretical knowledge. We need to make it by hand, and we encourage students to do it rather than think about it.
Exactly. That's how I feel. You can't really learn, there are things that you have to learn by sitting down and reading a textbook, especially things such as, early literacy, like learning how to read, how to write, how to calculate. But even those things you learn better by actually using those things
After you're making it, you will fully understand the whole project.
Exactly. Yeah. So that's what Kieran is talking about. And not all of his students are makers. They all don't just sit down and listen to a teacher telling them things. They actually participate in the learning, they design it, and then they create things, whether it's a new game, so they can build. He's talking about students making their own games, making their own cryptocurrency. They maintain machines that fulfill part of the blockchain responsibilities of maintaining the health of the blockchain. Amazing stuff.
Yeah, it would be a wonderful experience too.
Yeah, I wish I was a student again in his school. We actually thought about moving to Melbourne. I was thinking about it. So our kids can go to his school.
Okay.
All right. The next, the second presentation in this day is from Professor Richard Park. So Richard he's got a huge experience in technology as a professional. What he is focusing his time now is in teaching others about technology, and he does it through making. So in one of his courses, he is currently designing a whole curriculum to teach his students how to do internet, or how to build Internet of Things applications. And of course, the Internet of Things is not just one thing. In it, you've got so many individual components that have to play together. You've got the cloud infrastructure, you've got the internet infrastructure, you've got the microcontrollers and microprocessors, you've got HTML, you've got communications platforms and methods, you've got web browsers. The list goes on and on and on. And what Richard is doing here is he's showing us his process of creating this curriculum. And he's going to walk us through the experience that the student is going to have in the lab. So both how he did it and the experience of the student doing the work in the lab and developing this IoT application. And for me, what I really like about the work that Richard is doing here is that he doesn't just go out to a bookstore or to a website and buy a textbook for his students. He becomes a maker himself. He says, I'm going to make my curriculum because then I'm going to be a better teacher, so that my students then can learn from me if they need to, but they're going to have to do the work anyway. I'm just going to be able to be the mentor. You can't do that, if you just buy an off-the-shelf curriculum and just deliver it to the students. By the way, that's what I used to do when I was a university lecturer. My university would give me a textbook and say, Peter, this is what you teach next semester. So it can't work like that. All right, so that's Richard's presentation, day 6. The whole thing is dedicated to the Internet of Things. This is so huge, where we had to give it a whole day.
It's one of my favorite topics.
Our world is so noisy. Humans talk to humans, makes noise. Now machines talk to machines. That makes a lot of noise as well. Yeah. So now we've got a very noisy internet and a very noisy world, but I think it's a good thing. And the balance, it's also a good thing. So we've got Dal Gemmell, we've got Alain Penetrat, we've got Marco Schwartz. Yeah, 3 presentations here. Now Dal works for Helium. Helium is an amazing company. I've worked with their technologies in the past, maybe about 3 years, and I developed a few lectures for one of my courses. But things have moved so far in the last 2 years, and that's why I invited Dal Gemmell to talk about it. As I said, it's a noisy world. The internet is used right now not just by humans to check out YouTube videos about cats and dogs, but also by machines to talk to each other. And what Dal is doing, and Helium is doing, is that they realize that machines have got different requirements compared to humans. So the kind of chatter and the kind of talking that they do is very different to the kind of talking that humans do on the internet and the human needs for the internet. So what Helium is doing is that they are creating the infrastructure for a new generation of network that can be used specifically by Internet of Things devices. So that's what his talk is about. He's going to do a demonstration of the Helium hotspot and the Helium network. And he's going to connect an Arduino to the Helium network with just a few lines of code. Everything that Helium is doing is open source, including the hardware, so you don't need to use any Helium hardware. What is called the IoT 2.0 is totally open source, which is why I thought it's such a big deal. And there's a blockchain again. As I said in one of my blog posts, that the blockchain technology is a big deal. It's going to change everything, and it is already starting to change everything, not just in the financial sector, but Internet of Things, right? That's how this side economy is going to work. So check out Dao's masterclass. It's going to give you an insight of what is happening right now. This technology has been deployed, and it's just a few months ago, starting with North America, and it's moving to other parts of the world as well. It's never been easier to connect your IoT devices to the internet.
Yeah.
Right? 20 billion devices.
Yeah.
Right? Yeah. That's a big deal. All right.
That's great.
Yeah. Next up, we've got Alain Penetrat. So Alain is very interesting in many respects. One of those is that he is a self-taught electronics maker. His background is in software. He's a software developer. He's worked on security systems and still does. But what he's going to talk about, which is this system, the NoCan, came out of a need that he had as an individual. He wanted to build a security system for his apartment. And he wasn't happy with wireless solutions because of the problems that wireless solutions have, especially interference and powering the modules that are remotely located and so on. So he developed his own solution called NoCan, which is based on the CAN protocol. It uses wires, which solves a lot of problems. And he took the next step. The next step is to commercialize his technology. So he's a maker who learned how to build a new technology, developed it as a product, and then launched a Kickstarter to basically bring it to the market. And that Kickstarter was successful, and now you can buy NoCan, and I've got a few modules here that I'm working with and develop something using the technology that he developed. So he's going to take us through this whole process of how he did it.
That's
great. I also have, and he's amazing. And I also have a Tech Explorations podcast where Alain is the guest, and he's talking a lot about the background of how he did this. All right. Then the last presentation for the day is from Marco Schwarz. Now, Marco is an engineer, so he does have an engineering background, but he became frustrated with some aspects of the Internet of Things, especially like earlier cloud platforms would lock you into their platform, or would only work with a particular kind of hardware that they supply. And there's a few other problems as well that bugged him. So just like Alain, Marco decided to build his own Internet of Things cloud service. He calls it AEST, and he also developed a library to go with it. And it works. It's totally open source. You can have your own AEST node on the internet to connect your devices with. It works with pretty much anything that is compatible with the Arduino IDE will work with the AEST library, including the ESP32. And his presentation is amazing. Within a couple of minutes, you can have a node, comfortably sending messages onto the internet. And then you can also use your browser, and just by typing the appropriate strings in the URL bar, you can control the pins of your Arduino and also read values from it. So no code required. It's also very easy. It's just a few minutes. So that's Marco's presentation. Okay. Simon, this is the last one.
Last day.
Last day, yeah. So we've got day 7, right? So we've got 2 presentations here. There's Norman Pirolo and Vladimir Mariano. So these presentations teach us how to build things not with electronics or software now, but with wood and plastic, right? I think plastic is quite straightforward because most of us are familiar with 3D printing.
3D
So,
printing. Yeah.
Yeah. So this comes to no surprise that one of those presentations would be included in the summit. Many of us don't realize what modern tools for creating 3D designs and then modern printers and how easy it is for modern printers to translate those designs into a physical object, how easy those things are. And within the 1 hour that this presentation lasts, Vladimir is going to show us how to build a 3D object that is also printable. And he's going to talk a lot about the concepts, the design concepts, and some of the tools around some of the concepts that are important to know when you use any 3D design tool. What he's using is Fusion 360, but the things that he's talking about work with most tools, right? So this is pretty straightforward, and it's going to demystify how 3D design and printing works. But I find Norman's presentation very unusual because personally, and I think that is true for most people that I talk with, we are not really familiar with the oldest making material that existed. Okay, one of the oldest. It was like in the olden days, people used to make things with stone and wood.
Wood, yeah.
Yeah. So things like clay and materials like that used to be used, but wood in particular, because it was so flexible and easy to manipulate, unlike stone and other materials, I see it as the first material that makers used. But they've gone a little bit out of favor because 3D printing and other materials like metal have come through. And what Norman is going to show us is how easy it is to use simple hand tools, no power tools, but simple hand tools to build something beautiful, like a Japanese Kumiko panel. So I'm not sure if you're familiar with what Kumiko looks like, Simon. Have you heard of this before?
No, sorry.
Yeah, most people haven't, which is why you should watch this. So Kumiko panels are like structures made of thin pieces of wood that are about this big. They're typically rectangular, and you can put a lot of them together to create a whole panel so that you can use it to separate two rooms from each other, or it can also be used because it looks beautiful. It can be used as like an ornament. And again, as I said, you only need your hands and a few simple hand tools and a bit of glue, and you can do this. You can show us, and then you can express your artistic side by building Kumiko. As he was talking about it, I felt that he was becoming very relaxed, and so I was becoming very relaxed because, when you're building something with wood, you don't use a computer. And maybe that is an advantage. When you don't use a computer, you're not close to your email or to your notifications and to other distractions. So your mind can just focus on one thing. And that's why I said you can reach a sense of Zen by the time that you're done with it. And it's beautiful. And that's it, Simon. We're done. Go. And thanks again to PCB Way and Altea. I can't stop saying that.
It's our honor.
Yeah. So that is our lineup. I hope everybody will enjoy that. Is there anything else that you want to add here, Simon? I just have a few. We almost took to the end of this kickoff event. I've got a couple of other things to say, but if you want to also say something, please be my guest.
Yeah. After reviewing the speakers and their topics, I just want to join in this event, and I also want to start these topics. And it's actually not easy to learn on the internet and without the speakers. And I want to study with them and learn how they build the project and how the insights about in their fields. So it would be a wonderful and unforgettable experience for this event.
Yeah. I feel like that. Like I'm familiar with some of these technologies, but not with most of them. And talking to these speakers and then watching their presentations really make me want to take a couple of months off producing my courses so I can learn from the things that they have to teach. I'll try. I know it's very hard these days, but it's worth it. So I will try to do that. Okay, so there's just a couple of things that I want to mention for our audience, just a few housekeeping things before we finished, and then everybody can start watching the actual presentations. So the first one is the discussion tool. So let me show you. Here's Mark Wilson's presentation, and they all have the same structure. So we've got the video, we've got a bit of information about the presentation and the speaker, and resources. Down the bottom, we've got a tool for discussion. So we welcome your messages. Myself and the speaker will be checking these pages for your questions and your comments. Feel free to type them in, and then I will definitely check in and provide a response, and most likely the speaker as well. So that is a discussion tool. All right. You can also contact the speakers directly. In most cases, we'll have the direct contact details with the speaker's permission, so that you can always get in touch with them if you wish. Next, if you want permanent access to all of the presentations plus several other perks that are available, all the presentations in the summit, then beware that there is the premium pass. You can go to this page here and purchase your pass, and that means that you can watch all the presentations at your leisure for as long as you like. And as I said, there's a few other perks there, and the information about the premium pass is available in this page. You find this link in pretty much everywhere, like all the summit pages contain it. Now, if you need any technical support, just go to this help page. Again, you'll find the link to this page everywhere. Just click on support. It will take you to this page. There's a few FAQs. These may actually provide an answer to your question. If not, just ask away. And we are available to help you within a few minutes. Usually, as long as I'm awake, I'll get back to you. Okay, and that's about it. I want to finish up by thanking you, Simon, for joining me today and for your support, and on behalf of PCB Way again, and for being a speaker, of course. It was a pleasure having you.
Thank you. Thank you for inviting me again. And it's my honor to join this summit. And it would be a wonderful journey for everyone who join this summit and really learn a lot from today's even short description. I will also join the summit and learn from other speakers.
That's great. Thank you very much, Simon. Okay, and now I declare the summit officially open, and it's time to go and enjoy it. I'll see you all there.